Huygens principles, the proof for the laws of reflection using Huygens principles. So Huygens, based on the wavefront, he just proved the laws of reflection as well as the laws of refraction. The laws of reflection, which we know already, is whenever the incident ray touches the surface, it bounces back into the same medium. The I is the angle between the normal line and the incident line, and R is the angle between the normal line and the reflection ray. This we know what is the angle I and what is the angle R. The laws of reflection states that the angle I is equivalent to angle R. This we know, and this we are proving by using the Huygens principles, means in terms of wavefront. What is meant by wavefront? Always the wavefront is the line or the wave which we have taken, which we are always taking perpendicular with respect to the incident ray. So if you are taking the surface and the incident ray touches the surface, then you have to take wavefront by taking the arc which is 90 degree with respect to the incident ray. For example, see here I am taking the surface, and this is the one which we always followed. This diagram gives you the more explanations about the Huygens principles for laws of reflection as well as the refraction. You can take in any book, but in the state board book it is given very clearly, the diagram as well as the explanation. I think that will be more good. And the incident ray which touches the surface, I am taking 3 incident rays which touches the surface. All the 3 are parallel, one with respect to the another, and it touches the surface, and this is the surface which I am taking. Surface, the incident ray, I am naming it L and M, and it touches the surface. Here the surface is taken as X and Y. Okay, then what is happening? It is getting reflected. All the 3 rays, I have to take the reflected ray, the first one, second one, and third one. So if you go for with respect to the normal line, we have to take the normal line. So take the normal line, take the normal line, angle between the incident ray and the surface, we don't know, but the angle between the incident ray and the normal line, which we know is I, and the angle between the normal line and the refracted line, which we know is R. So this is the known things to us. Already we know these things, that what is I and what is R based on the laws of reflection. And in optics also we study the same thing. What is meant by angle I, what is meant by angle R. Where it touches, the first incident ray I am considering, where it touches the surface I am taking as A. Okay. Now I have to take the wavefront for the incident ray as well as for the reflected ray. So take a 90 degree with respect to the incident line, and that is known as the wavefront, which is AB. So AB is the wavefront. This is incident ray, and the angle between the incident ray and the wavefront should be always equivalent to 90 degree. We should be very careful. The angle between the incident ray and the wavefront should be 90 degree. So you just mark an arc here, and which by using the scale you can easily get what is the 90 degree value. You can get what is 90 degree from the A point, and that point I am taking as a wavefront point, which I marked as B. Now with respect to the reflected ray, this is the third ray which touches the surface, and this is a reflected ray which comes from the surface, the first signal. And now I have to take the 90 degree wavefront value with respect to the point. Here I am taking as A dash, and I have to mark the B dash. B dash is taken 90 degree with respect to the reflected ray, and so this will touch the point at this. You can mark that line, and the angle should be, these two should be 90 degree, and mark that one as B dash. So what are all the two wavefronts? One is AB and the another one is A dash and B dash. These are all the two wavefronts. So now it is clear. Next we have to look, I have to prove it. What is meant by angle I and what is the angle of I in terms of wavefront. This is what I have to prove. So as I know, the angle I is nothing but L, A, and the normal line is taken as N. So what is angle I? Angle I is nothing but L, A, N. Or you can write NAL, no problem, but it should be at the point A. L, A, N is the angle I. And now I know the wavefront is with respect to the incident rate 90 degree. So if I am taking this value, maybe of any value which is X, then I can write the angle I plus angle X is equivalent to 90 degree. So what is angle I from this equation? That is 90 degree minus the angle which is X. What is that X? That is nothing but 90 degree minus NAB. That is NAB. Clear? So this is I don't know, which I don't know, but the sum of I plus X I know, which is equivalent to 90 degree. So 90 minus this X is equivalent to I, that is 90 minus NAB is equivalent to I. Now with respect to the surface, the first one with respect to the wavefront and second one with respect to the surface. If you go with respect to the surface, the NA dash is degree. We know that NA dash is equivalent to 90 degree. So something X plus some other angle should be equivalent to 90 degree. So obvious that angle will be the equivalent value which is of I. Because I is 90 minus X, and here this angle also how I will get, which is 90 minus X. So 90 degree minus X gives you the another angle with respect to the surface what the wavefront is making, that is also angle I only. So I can rewrite this equation, the same equation I can rewrite in terms of the surface, that is angle I is equivalent to angle, what is it, B A dash. How I can rewrite? B dash, because NA dash is 90 degree, 90 minus X will give you I. So I can also be rewritten like B dash. Clear? So this is the thing with respect to the incident ray, and with respect to the I we got, if this is the angle I, here also it will make the angle I. Similarly, we can prove for R also. For the reflected ray also we can prove in the same way. That is, take the first angle R with respect to the wavefront and next angle R with respect to the surface. So if I prove this one, then R is nothing but, angle R is nothing but, this is L, so which is transmitting here is reflected here is L dash, and this is M, which is reflected from the surface is taken as M dash. Then what is R? R value we have to find out. So what is R? R is nothing but, this is N dash angle N dash A dash and M dash is the R value. N dash A dash and M dash is the angle R. So R I got now. Now with respect to the wavefront, the same R can be rewritten as 90 degree minus something which is X. This here I don't know, which is nothing but angle B dash, A dash and N dash. See, this is 90 degree and this is R. So this value X which I don't know, that is 90 minus this B dash, A dash, N dash gives you the angle R. Now it is okay with respect to the wavefront. Now we have to see with respect to the surface. With respect to the surface we have to see what is this angle. So this angle is nothing but, again what is the N dash, A dash and A is equivalent to 90 degree. This is a perpendicular line which is drawn with respect to the surface. So this angle is 90 degree. I want this angle is 90 minus something which is same equivalent to 90 minus, what is this one again, B dash, A dash, N dash. So if I subtract the B dash, A dash, N dash with respect to the surface, this angle will be equivalent to R, which is nothing but the angle R. Okay. So incident light, what is the angle I? R value we have to say. The similarly what is angle r with respect to the reflected surface. So we should be very clear with respect to the wavefront what is I, with respect to the surface what is I, with respect to the wavefront what is r, with respect to the surface what is r. If you have got this equation, then here we will be getting I and this angle will be equivalent to r. Next, we have to see the triangles. What is the first triangle I am taking is at the incident light, the triangle A, B and A dash. Triangle A, B and A dash, as well as here A dash, B dash, A. Two triangle with respect to the wavefront. This is first one, okay, and this is second one. So take two triangles, that is wavefront and the base, which connects the wavefront and the base. So A, B, A dash, first triangle. Second triangle, base remains same. A dash and B dash, both are similar triangles. And here I know with respect to the incident light, if this incident touches the surface at this point, the third incident, why I took three waves. The third wave M touches this point, reaches this point, this distance and this distance will remain same. Why? Because it is getting reflected in the same medium, the speed of the light will remain same. When the speed of the light remains same, with respect to the time it remains same, time period same, velocity same, means the distance travelled will also remain same. So in this incident ray travels up to this distance, at the same time only the third wave touches the surface. So this distance travelled by the first wave and this distance covered by the third wave will remain same. What are all the things now we should be very clear? The base of both the triangles means the distance A dash remains same for both the triangles, as well as one of the another side. A B dash is equivalent to A dash B. So this distance and this distance remains same. And what is the angle? Here also it is right angle and here also right angles. When two sides as well as the one angle of the triangle remains same, they are similar triangles. So if I am taking this one as a similar triangle, this I will be equivalent to the R. Another angle will also remain same. This is what Huygens proved, that angle I is equivalent to angle R. So hence the laws of reflection is proved based on the similar triangles which is formed by the incident ray. Here I took three incident ray. In some books like NCERT books and all, you may see only one incident ray, means two incident ray, not the middle one, first one and third one. You can follow anything, no problem at all. It is better to go with the two rays, no problem. You will be getting the same thing. We should be very clear that the incident ray travels in the same medium where the reflected ray also travels, right? Or we can say the reflected ray travels in the same medium where incident ray touches the surface. When according to the laws of reflection, both the incident ray and reflected ray, they are at the same medium only. So the speed of the light remains same. When speed of the light remains same, here whatever the first incident ray travels, the distance, the third ray would have touched the surface after traveling the same distance what the first incident ray traveled. This distance and this distance will remain same. This is what at the last we have to be very clear that how it is similar triangle. So Huygens principle to prove the laws of reflection is over. The next video I will see with respect to the another topic related to the same or some other topic. See you. Thank you.